Alright, so come on right here. So to set this up, the customer would have to first put it in the correct direction. So we have a compass here. So if we're in the northern hemisphere, you want the motor end south, and if we're in the southern hemisphere, you want the motor end north. So we can use the compass to do that. We also have a dome level, so they can make it level, so that's how the tracker works. And so what they would do, this would be, so that disengaged the motor. So now it's free to rotate, so there's no stress on it. So what they would do is they'd wait until about midday, and you can see the shadow be cast on the little plate. And so they would adjust this so that there's no shadow. Come look at this here, Scooter. You can show this right here. They look at this protractor, and when it's directly level, they'd engage the motor.
Behind that, I got them all. I guess there's a little
Cool. And then you have the sun. So when there's no, look at this. When there's no shadow generated from the pin, they know it's at noon and it's at the correct declination angle. And when that happens, they would run the code. Let's see.
If it runs fast, you know you got it.
So then this simulates the code. It runs from noon. It tracks the sun through a mathematical program, and it waits till it goes till 5 p.m. clock time, and then it sits at that location, collecting the last bit of sunlight. And then at midnight clock time, it'll quickly rotate back, and then pick up the morning light and then track the sun throughout the day. So we needed this geometry to work without the sun casting a shadow, or the tracker to cast a shadow on the panel itself when we're at the negative 23-degree angle right here, because on the equator and near the tropics, the sun is going to be moving north above you a certain amount and then south. So we need it to be able to have this panel tracker work on any latitude. So that's why we have that geometry. And so this drum arm allows us to adjust the declination for the sun. So throughout the seasons they could change this, and then the whole panel will shift. We got a counterweight so that the motor can do less work, turn the whole thing. We have bearings in there and little collars to hold the geometry in place. We got a cable to hold the frame together. We got feet that can be buried. Is that working? Here are some prototypes. Legos. Shows this. Here's another one. Here's our board.